Hello everyone. Today we are going to discuss SMAW and GMAW. The content of the presentation are shielded metal arc welding and gas metal arc welding. First we are going to discuss shielded metal arc welding. It is an electric arc generated welding between a coated electrode and the parent metal. The coated electrode carries the electric current to form the arc, produces a gas to control the atmosphere, and provides filler metal for the weld beam. Electric current may be AC or DC. If the current is DC, the polarity will affect the weld size and its application. As shown in the schematic, we can see a power supply is connected with the workpiece and the electrode holder. A shielded uh, gas is used for environmental shielding. Now we are going to discuss the process of shielded metal arc weld. An intense heat at the arc melts the tip of the electrode. Basically, in SMAW, an intense heat at the arc which melts the tip of the electrode. Tiny drops of metal enter the arc stream and are deposited on the parent metal. As molten metal is deposited, a slag forms over the bead, which serves as an insulation against air contaminants during the cooling. After a weld pass is allowed to the cool, the oxide layer is removed by chipping hammer and then cleaned with a wire brush before the next pass. Next topic is gas metal arc welding. Gas metal arc welding is generally known as MIG welding or metal inert gas welding. MIG welding or MIG is an acronym for metal inert gas welding. MIG is a commonly used and accepted slang term that was appropriate when the process was first. In the beginning, the gases used for shielding the weld area were known as inert or noble gases. Today, the proper terminology is gas metal arc welding or GMAW. GMAW uses a consumable electrode as a filler wire made of the base metal, as we can see that in the schematic. A consumable electrode is held between the drive wheels. Argon as an inert gas is used typically in the gas metal arc welding. The schematic shows the process of arc welding, where an electrode holder holding the wire, guiding the wire, and welding the base metal. A shielded gas, a shielding gas, is shielding the welded environment or welding environment. Now we are going to discuss power supply and the equipment. MIG welding power supplies are referred to as CV or constant voltage power supply. What this power supply does is produce electrical current to create an arc to weld the metal with the wire. The term CV means that the heat settings are controlled with voltage. When MIG welding, the machine is always set by a voltage, and this type of power supply keeps the voltage at a consistent level. What happens is that the amperage MIG welding requires a wire feed system. The wire feed system is what feeds the electrode or filler wire to the weld joint. This is where the term wire wheel welding comes from. The wire feeds come in many different forms. Some are part of the power supply, and the higher end models come in standalone form or contained inside a briefcase. Since the electrodes are solid metal wire, they always need some form of shielding from the air. The gases range from inert gases to reactive ones. In many cases, the gases used are a combination of two or more gases. Some of the commonly used gases in GMAW are argon, carbon dioxide, helium, and oxygen. For most welding applications, a combination of argon and CO2 gases are used. When it comes to the welding gases, argon produces a cleaner weld and the carbon dioxide helps the weld penetrate deeper. Carbon dioxide can be used alone for thinner metal, but it also produces a lot of smoke while welding. Some of the most commonly used gases for welding mild steel are 100% CO2, 25% CO2 and 75% argon, 2% CO2 and 98% argon. So these are some typical combinations which are used to weld the mild steel. The mixture are referred to as C25 and C2. The C stands for carbon dioxide and the number is the percentage of carbon dioxide in the mixture. It is assumed that the rest of the gas in the mixture is argon. Argon by itself is used for welding aluminium, copper, nickel, and titanium as well. So these are the some references for the content of the slides. Thank you so much.